Equilibrium, lesson number 6, the equilibrium expression, and KEQ. Consider the following equilibrium. We can write out an equilibrium expression with the symbol KEQ. The equilibrium expression is conventionally written as the KEQ is equal to the concentration of the products divided by the concentration of the reactants. Therefore, from the above equation, we can write a generic KEQ equation based on our formula, products over reactants. KEQ is equal to the products, concentration of C, times the concentration of D, divided by the concentration of A, concentration of B in the denominator. The coefficients, the lowercase letters, A, B, C, and D, actually become our exponents in our expression. So there is our KEQ expression. The numerical value of KEQ is called the equilibrium constant. Let's write the following as equilibrium expressions. For the first example, products over reactants. Since all of the coefficients are 1, we will not write a 1 as an exponent for the first example. For the second example, KEQ is equal to the products. The coefficient 2 becomes the exponent 2 for NCl3, N2, exponent 1, which we don't write, Cl2, coefficient 3 becomes exponent 3. And there's our KEQ expression. For the third example, N2O5, exponent 2, NO2 to the fourth, O2. And there's our KEQ expression. If you notice, all of the species up above are all in the gas phase. Only gas and aqueous phases are included in the equilibrium expression. This is because the KEQ expression only includes species whose concentrations can change. Let's look at the solid and liquid phases. Solids cannot be compressed, therefore they cannot change their molar concentration. Solids are never included in the KEQ expression. If we were to write a KEQ expression for this equilibrium, KEQ be products reactants are just a solid, so just over 1, or quite simply, we could just write this as Ag plus squared CO3 2 minus, and there's our KEQ expression, not using a solid in the expression at all, as it does not have a molar concentration. Pure liquids. Liquids cannot be compressed. However, if there is another liquid present, it can cause both liquids to become dilute, therefore changing the concentration of both liquids. A liquid is said to be pure if it is the only liquid which exists on both sides of the equilibrium. If the balanced equilibrium equation contains a pure liquid, it is not included in the KEQ expression. For the next example, we have a pure liquid, which is chlorine. Since it is the only liquid present, we are not going to include it in our KEQ expression. And our expression becomes products, HCl, exponent 2 over H2. And there's our KEQ expression. The next example has two liquids present. So in this case, since there are two liquids, we do not have a pure liquid, and we must use both of them in our KEQ expression. Products over reactants. And in our next example, we have one liquid present, which is a pure liquid. We also have solids present, so we do not include any of those. Our KEQ expression here is simply Br2. In summary, because the concentrations of solids and pure liquids cannot change, adding them as a reactant or product to a system in equilibrium will have no effect. Therefore, when writing a KEQ expression, solids and single liquids or pure liquids are never included, whereas gases, aqueous, and multiple liquids are. The Hebden assignment for this lesson is page 60, numbers 31 to 35.